Good morning, everyone. So for today, let me just make it better. So, hello to everyone that is watching me today. Thank you all for joining. As I said, uh, today webinar is not really a webinar. It's like ask me anything. So that's my plan for today. There is no really limitation on time. I think we can keep it under 1 hour, but we'll talk about it. Few things maybe before we will start, as this will be driven by questions. So I will show you very short presentation about it that I prepare for today. And one very important thing, I'm testing today live streaming to both LinkedIn and YouTube. So it is part also of my test. So let's start. And of course, good morning and good afternoon to everyone. I don't know what kind of time zone you are joining me today, but let me show you a few things. I prepared a bit, not really a presentation, that's not the goal for today, but something to drive through the webinar, to the ask me anything questions, just to give you some idea. So once again, good morning, everyone. My name is Marcin Ruta. For those who doesn't know me before, here I am. I'm busy with power system engineering. You might see me a lot around Arclash posts on LinkedIn, at least. And this is one of the big part of my work. I'm advocating a lot about electrical safety. So last week I went over 10,000 followers. So thank you for that to all of you. It is kind of not surprised, but it's very nice to see that people are really following what I'm writing. Interesting topic. Maybe I think it's not maybe that for you, but I generally started the second company, so where I can actually grow my team. So this is very interesting for me personally, and I'm looking for people to hire, especially sales representative for myself, for my own company. And for today, as I said, um, this will be purely Q&A question. So I will give you some idea what we can go through. And I'm generally recording this, so it will be available. I know it will be available on LinkedIn Live later on, so you can always watch it later if you miss it now. But let me go back to the stream. And yeah, I can. Good morning, Graham. Good morning, Mark, Eric, Shalambos. Sorry, I don't know how to say it really well. Good morning, everyone. I don't know if we don't really wait. So if you have a questions, please type in chat box. I will show it live, and then we can go on. Generally, if there would be not that much questions, I have my own, so I can always point it to a lot of people. So take your time, think about it, and I will do some basic stuff that we have to go today. So generally the questions, because the questions are about the Arclash, so my plan was, okay, let's show what Arclash is. And this is something which I use, and this is from my Eton time. As you see, source is Eton, but it very well explains everything. So if you've never seen Arclash and you would like to put it on the small pieces, generally Arclash is current flow through air, or mostly through air, but it might be some different environment as well. And because of this flow, it creates the plasma and it creates a lot of temperature. Actually, it's 19,400 something Celsius, which is huge amount. And this is the main issue that we will be focusing on. So the temperature is the biggest problem than the thermal energy here. And this is what we would like to be protected against. But there are a few other things that you have to keep in mind, which are like the expansion. Because of this temperature, copper will evaporate or aluminum will evaporate. and because of this evaporation, it will turn to gas, and it's a huge amount of gas. As you see, like 67,000 times expansion. Um, it is a lot. So just to give you an idea, it's like if you turn 1 liter of copper to gas, it's 67,000 liters of copper gas. Not exactly, but as an example, it's good, I think. Because of this temperature, you also have a hot air around. So this thing, I think you should see it here. There's a lot of intense light. So if you have any direct relation to welding, that's generally something like this. But this welding is very controllable process, and this is something which we don't have control at all. The only thing we can do is switch it off if we are lucky and everything was done correct. There is a pressure wave, and this topic is, I would say, it is there. It is identified that the pressure wave, the pressure rise, might throw away people away. And at least the problem I have with it is there is no really evidence of things that might be that killed someone because of the pressure wave from arc blast. That's what we call it. That's the arc blast. And other topic is that even if you calculate it, and I might write it as a comment here, I said as a comment and my opinion, that even if you identify the pressure wave, the only thing you can do is to limit the time if possible. But if you are on the bottom time, there's nothing really you can do. You can try to limit the current, which, let's say, on the just on the transformer side, low voltage side, is not that easy. And yeah, and at some point you end up with the problem, really, which is a little bit different when we talk about the instant energy than the arc blast. So this is interesting topic. I haven't seen it. So I see there is a first question coming from Kamesh. Let me drop it here. So Kamesh is asking if we need to do Arclash on 230 volt one phase system. Simple answer is yes, and it's not because I want to have it, but for the first thing, one phase systems are not really included in IEEE 1584, and we treat three phase to one phase more or less as one to one, as a rule of thumb. The other point with 230 volt is, as a test, as far as I've seen and the reports, it is likely to keep Arcflash sustainable, so it can keep going. It will be, yeah, technically it should be on the low side, but because of the voltage is slightly above the IEEE equation, which is 208 volts for US NC codes, we still keep it in. But and the problem is that you keep this 2000 amp short circuit current level for 230 volts, which means there's quite some location. But don't expect that this will be a huge amount of energy. This usually will be something above 1.2, but it's not like you see 40 calories or 20 calories. But this is something which generally has to be addressed well. Still. Let me check. There's a question from Mihao. It's a long one, so let me read it. So our client wants to do live working on low voltage overhead line. He asks us for help in PP selection knowledge. Has his 400 volts. How can we help him? So low voltage overhead line, it is below 1000 volts. So if you need the PPE, then and the live working, we have there is a standard for live working. So normally, aside of the PPE that we talk about, live working means that we will work on live equipment and we need to follow, I think it is ISC 60481. This one, if I'm just typing now from memory, where one first thing is important is PPE. So that's a base because they need the PPE, but they also need special tools for live working, which is different. They also need the documented training for live working. That's very important. So we know that they all know. So they have to go all those steps. So if we can help them, to be honest, First, they need to start with training. Once they understand the training and they understand the risk related with the live working, because then there will be a risk of electrocution, there will be a shock hazard, there will be a risk with Arclash as well. There is also risk of electromagnetic field, but I think it's treated different if you generally work there. And once they finish the training, once they finish everything and they are certified, then they can have a PPA, then they can go work. And to be honest, in my feeling, they should go with someone that has already experience. So being, let's say, passed, not just thrown away to the work. I hope this answers your question, Mio. Let's go with this one. So there is a question from Jahanzip. Sorry if I said it wrong way. This is long question, so I will try read it because you don't see the full one. So Janzi wrote, I have a question regarding low voltage breakers in panel boards. Usually they are within the range of 100 amperes to 20 amperes. Usually the breakers are not completely coordinated this ampere rating, but client requested to provide complete coordination, which not only changes the size of the breaker to 250 ampere or above, but also the risk of increased Arclash hazard due to time coordination. How do we explain it to the customer and convince him? So again, I'm kind of guessing now because I don't know what your system is, but if you have to coordinate the fully 400 amp with 20 amp breaker, it's possible, it's quite easy. You might not see it on the coordination charts if you go to the time current curves like in EWSKM or other software, because you might see that they are not fully coordinated graphically. But if you have a problem like this, you go to the coordination tables, for example, from Schneider, from Eaton, from Siemens, from ABB. They make a coordination by tests. So they have to test the worst case conditions for 2 sets of breakers, sometimes for 3 sets of devices, like diffuse with breaker, ACB breaker with MCC breakers, MCCB with MCB, so miniature cyclic breakers that you talk about. And then you can check what is the limit. And generally, this is energy coordination. Not every software can allow you to see this, but typically you can find the table, you can find the charts, you can even compare it. What is the transfer energy? And this is based on current limiting effect of the upstream breaker. So, but don't mix it with the backup coordination. This is something different, or backup protection. You have to go to the coordination table and it will tell you that, okay, up to 10 kiloamps, up to 20 kiloamps, this combination is selective. But this doesn't work across two manufacturers. They don't do cross test. Again, good morning for everyone that joined us now. So the question from, sorry. You have to tell me how to spell it. I'm not that good at this. But what is the maximum incident energy in calories per square centimeter rating available in the market for the Arclash suit? So as far as I know, and this will be kind of commercial now, because I have provided for the customers of mine on some projects, the highest one is 140 calories per square centimeter. And this is something that Oberon does in US. And in Europe, so as far as I know, we have up to 100 calories per square centimeter. So this is the at least for the suit. So this is the maximum rating I'm aware. And typically you find a lot of things up to 40 calories. But if you would like to go above, it's not that easy to find it. Let me find one thing. Okay, that's a good question from Hicham. Are the Arclash on solar DC same damage on the AC current as the solar DC more than 250 volt DC? So technically not, because you have more power in DC systems, like RMS power. The difference is also that we don't have a... I can actually show you a video, because one of the presentation is video, which is going from DC. So not this one, not this one. So this is solar, arc. I don't know what kind of voltage it is. It's not given. But if you look at it, you will see that there is a constant power flowing. Energy it very depends on configuration of the network. Typically, they are not like 40 calories because you have less available short-circuit power usually, but on 50 megawatt system it might be different. And you also have a power electronic that's supposed to limit the current. It's getting complicated at some point. But typically, DC should be higher than AC because of the you don't have a flow and a sign, and it's constant, and we don't have a crossing zero, and it's also very hard to trip it at some point, like if you don't have a proper equipment. Let me go next. So there is a question from Ian. If you have a low voltage switchgear which is internal arc tested to ICTR 61641, do you need to carry out Rflash calculation? Yeah, this is interesting topic, and I think I talked about it in the myths before. So IC 61641 for arc, let's say rated or arc resistant switchgears is very nice thing to have, but it is for the low voltage switchgear. The problem with it is that if you work on low voltage, it's very easy to open everything. And for example, you do some infrared scanning, you do some testing, you do some measurements. And at this point, you don't have your rating anymore. And so typically, yes, you need to do Arcflash calculations just to know what is your Arcflash incident energy at this switchgear. If your time is not too long, because it might be that your switchgear is tested for 300 milliseconds, which is typical for cable connections. And I can tell you that 300 milliseconds on the incoming cable connections is very low time because it will be protected by medium voltage protection, and it's typically always higher than this. And so you might see that, okay, you have it. Maybe you have a 1 second rating. There are different solutions. But yeah, you need to carry out Rflash calculation. This thing is not really solving arc problem, is keeping it away from people. So just because you have arc tested switchgear, it's a very nice thing, but it's partly solving the problem, I would call it. And there is a very nice report. I don't know if you see this, but the cotton that is tested, because we tested with the cotton material around 30 centimeters around the switchgear, and if this thing doesn't ignite, then it's okay. And people think that they can walk across or stand in front of the switchgear like this, doing some switching, or maybe something is wrong, but they are standard because it is arc rated and it's supposed to be safe. And they might wear something like like this plastic clothes, I can call it, like polyethylene or whatever, and this thing will ignite. That's the conclusion from the test, that this is not cotton, so you have to wear something more than cotton still walking around the arc rated switchgear. Otherwise, if you wear something different, you might ignite as well and get burned. I think Mark is referring the question about ATP or EBT from the previous. So it is generally this is the same thing, different tests, of course, but ATP rating or EBT rating is both calories per square centimeter or joules per square centimeter. So 100 calories or 140 calories. I think it was ATPV test that time, if I remember. It was not tested for EBT. Question from Callum. Martin, have you done alpha studies for system above 15 kV? Which methodology do you use for it, since outside the scope of IEEE 1584? Yes, I did, actually quite a lot. So there are a few tricks I can tell you. So if you go above 15 kV, which is the very common voltage in Poland, for example, we sometimes have systems which are 15.75 kV, which are slightly above IEEE equation. So if you have something like this, and it was tested that we can extend with results are still okay up to 36 kV. So generally speaking, you can. What I do there, just for Arclash, I just change the voltage to 15. No, just not to have the error in software, because if you calculate manually, you will see not big difference, actually no difference at all. But if you run it in the software like SKM or DTAP, it will just tell you it's an error and immediately switch to Lee equation or something different. So generally, I just adjust the voltage to proper level for Arclash, and it doesn't make a huge difference. This is more for load flow. And if I go really above 15 kV, then ETAP has very interesting module which is called oh, I lost it, but it's I think called ArcFold, which is generally above 15 kV up to 400, I think, which is based on, as far as I know, they base it on Arc Pro. So they compare it, benchmark it with Arc Pro calculations and on the APRI tests to have the same. Otherwise, if you go with Lee, it's very conservative. It's really going very, very high, very fast, which is not true if you look on the tests. And if you go with straightforward IEEE 1584, it also goes a bit too high. So generally, I use Arc Fold from ETAP because it's more or less the same as Arc Pro. Not the same, but it's the results are very, very similar. Okay, so I think I didn't answer Michał's question, so he clarified for me. So the client asked to select PP for the electric arc. He has all the entitlements to execute low voltage. He has all his hand tools and equipment. So if they need to work on live equipment, so overhead line or something like this, or live equipment, the best thing we can do is uh, one, to make just the calculation to find out. I think I know what the problem is coming from. So there are two ways now. One way is if he looks for specific site like the production facility or I don't know, automotive, whatever. This is like the factory or a private network. So then we try to base it on the calculation so they precisely know what kind of PP they need to use. Other thing is if they work randomly live, so someone is calling them, go here, work live. Someone is calling them, go here, work live. It is overhead line, is it low voltage switchgear, some kind of connection. Then the things are getting more complicated because they, at the time they always go there, they have no idea what is the energy. And the only thing they can do, they can follow so-called table method from CSI Z462 or from NFP 70E, where the table method is just simple try to estimate energy based on previously done calculations by IEEE committee. When they would tell you, okay, this is a low voltage switchgear, we have a distance, we have a voltage up to 600 volts, we have energy, we expect short circuit current to be 50 kiloamps, and the breaker should trip in 100 milliseconds. And then you assume, yes, we have PP category 2, maybe PP category 4. I can tell you this thing goes very fast to PP category 4. And there is no below 1.2. I don't know if someone noticed it, but table method is always PP category 1, 2, 3, 4. There is no category 0 that you don't need your PP. But of course, this is not for the line working, live work execution. I hope this explains now. Thank you, Ali, for sharing webinar content. Thank you very much. I appreciate it. So there is a question from Hannah. Are lower or higher voltage transformers more susceptible to Arclash? I would say higher voltage transformers because of the lightning and all the isolation deterioration and so on. But it very depends on maintenance, I would call it. So there was a recent accident in Queens, I think last year, but there was a recent one like just a few days ago, as far as I know, also in Queens, on transformers. So I would call it like if you don't know what you are doing around transformer, which is live, it's very easy to create Arclash. Is it easy to? I don't have any statistics, to be honest. This is just coming from my opinion that if you have a high voltage to low voltage, let's say 15 kV or 36 kV to low voltage system transformer, usually in a production facility, they look at it, they clean it from time to time. And as far as I know, if someone doesn't overload it, then usually Rflash is not a problem because there's very little people around, and they are closed most of the time. If it is, I think it's more question if it's inside or outside transformer, because this will probably bigger influence than is it low or high voltage, or high voltage medium voltage, or medium voltage to low voltage. But to be honest, I haven't seen any statistics on failure rates related to Arclash. Sorry. I just to confirm, as a comment from Ahmed to Ayan, that yes, we sometimes open the doors in arc-rated switchgear. So it is good solution, but it's not solving everything. You have to keep this in mind. That arc rating is. I didn't mention it because arc rating is very like internal arc classification is almost like now mandatory, or almost include 9 out of 10 switchgear or 99 out of 100 switchgears on medium voltage. They will be tested according internal arc classification. Uh, from low voltage equipment, it's rather 1 out of 100 that has some kind of arc rating. And I think it's because it's bringing the cost up, and it's, I think, probably much more practical to install Arcflash detection system, Arcflash relays, than make switchgear arc rated if people would just go there and open everything eventually. Let me check. So, question again. Okay, you write a long question, so I can show it, but I have to hide it here to read it. So, as per IEEE 1584, if the main integral overcurrent PD is not adequately isolated from the bus, the upstream PD must be considered as protection the line and bus. I have the MCC with form 4B, but it is not metal clad, so I still go for upstream PD protecting line and bus. Yeah, this is more or less design based. So depends what you, if you use SKM or ETAB, you can deselect it. But I always check for line side, and this is simple thing. If you look on the, it's like very simple decision. If you have a small distribution board like panel board, when you open it, maybe I can have a slide somewhere here. Wait a minute, because it should be yeah, it's damaged, but as an example. But if you have something like this, when your main is somewhere here, I don't know. But if you generally open it, you see the whole panel with cables in, cables out, all the equipment, control equipment. Then yeah, you generally, your line side is the energy for the whole panel. Despite that you have some difference between bus and line, you take the line side as the worst one because you can see everything there, and it's big chance that this thing may happen. But if you have a panel like this is not a good picture, but for example, if you have something like this, when you have a MCC, let's assume that was the main panel connected by busbar, whatever, and then you have a lot of feeders. Then this section will be your line. If this is 4B, it's separated as well. So this is your line, and the line is actually, and then you consider the upstream protection. So generally, I do it all the time. I actually don't really remove line PD from the calculation. It's because I know what you are. I think thinking that if you just take into account the breaker, and for this whole thing, you just consider that this breaker protects both sides and this is line, and this is not fully correct. So I would say, and that's what I do. Always include the upstream protection for the main breaker, and depends on the design of the panel. You just decide, like in the big MCC, that okay, this one panel is line and load on the cable on behind the breaker, and the rest is generally load side of the main breaker, which is now called bus. Depends how you call it. So you actually have two energies for the bigger switchgears and one energy level for the smaller distribution boards. But it's really related with the design. So I just to keep it simple, that's how I do it all the time, and it's much safer this way. Yes, Stefan. Yes, this will be recording will be available for the future. Also on my YouTube channel. So if you didn't know, I also stream to the YouTube channel. When the recording, I have to play with it. But yes, it will be. Um, so you have some discussion here, but what I can say again, it really depends how it is done. If you cannot open the panel at all, so you have all the interlock and like on the medium voltage switch gears, where you physically cannot do it, and it's built in, and no one really wants to do it this way, then I would say at least you need to check if your arc rating is proper. So you might skip this panel, but you have to do a calculation for everything else. So as well, just from practical point of view, what I can say, you never do calculation for one panel. You always do for the system. So the fact that one panel is arc rated, it will be a nice thing to have. We will just include it. We'll include this information, take into account. If things will be, let's say, 20 calories, 40, 30 calories, but it is in the design rate range of the arc rating of this panel, then usually my comment is that yes, for operating for this, you don't need special PPE because of the arc rating of the panel, and we are inside. But it's sometimes it happens a few times in my projects that the panel was arc rated also on medium voltage and low voltage, and the rating was not correct, was too small, like let's say 16 kiloamps half second, and we went above 16 kiloamps. And or for the low voltage it was 50 kiloamps, 300 milliseconds, and we went above 300 milliseconds. So these things happen, so that's why we generally include this topic. Well, this is a good question from Darren. When doing Arclash studies, do you consider risk to operator in accept higher incident energy when where remote switching racking is utilized? Um, I would say this is not still a risk. What you, as an example that you get, because so this is called Arclash risk assessment. Yes, there is a risk assessment behind this. I would say that for me, risk assessment is a very gray area topic because, as far as I know, risk assessment is a topic where you calculate the probability of things to happen. You know the hazard from calculation and overall risk or severity, how you call it, and you have over risk results. The point is that if you have you, let's say, risk out, I don't know how to call it in English, your location. So, for example, you have 40 calories, and you say, but the probability is very low, and you have a moderate risk or medium risk. At some point, you have to say, okay, we need some extra measures, so maybe we just need to go away, use remote racking. Yeah, that's one of the solutions. This is engineering controls or procedure controls, as you can say. The other topic is, but does it allow you, for example, if you have accurate switchgear? This is one of this engineering control solution that might be done. The other topic is if we have 40 calories and you say that it's very, very unlikely for things to happen, and we end up having somewhere low risk because you might do it actually. This is on the paper, and you have a low risk. Does it mean that I can go and do measurements or some other things? Because you have to do risk assessment for a condition of equipment at this moment for task you are doing. So this is very long list. I'm not against it because I have a lot of ideas how to actually use this to make this thing better. But it requires, I would say, a bit more attention and it's supposed to be a bit more precise. What means what? How you go? Because I've seen a lot of the risk tables, and to be honest, I'm pretty sure I will make. I could make most of the projects low or medium risk, despite they are above 40 calories, which I think it will be not reasonable. So technically, my approach is that what we do for a moment in all projects is that yes, we do calculation, we do recommendation, which is already engineering controls. So we try to reduce the energy and eliminate, reduce, and do engineering controls. Sometimes we install Arclash relays to make it much lower energy, and then we match procedures, or we use what you have on site, and then we follow with PPE for already lowered energy. So instead of 40, we have 6. Instead of 20, we have 3 calories, for example. So that's the idea, what I focus on, just to go with some clear results from calculations. But if you have remote switching, if you have remote tracking, if you have any, for example, last time I seen a remote starting switching panel, which was stupidly mounted next to the breaker, but I just thought, okay, I just put it away on the end of the switchgear and then operate it, because this would be easier and safer, not standing next to the breaker and using the remote panel. So those kind of thing. I'm not sure if this answers your question, but because risk assessment is very flexible topic. So, question from Donato: how do you prevent Rflash on PV? Well, PV is interesting topic because so I actually planned the webinar. I think next or second webinar will be on DC Arclash, and so PV itself depends what kind of PV installation you look like. Is it commercial, like on the house, on roof, or is it a big one, which is 10 or 50 or 150 megawatt PV farm? And the main topic is, from my experience and from my view, is how you design the system. So if you have a lot of microinverters, if you have a lot of this concentration box, if you have a big inverter on site, like few big inverters, but not one, and this makes a difference. And especially if you connect it with the battery storage system, it's making this bit worse. But generally speaking, with DC, with PV, the problem is that the closer you are to the source, the harder it is to switch it off. So the video I showed you before, maybe I can come back. This is an example of it. So this thing, let me go back. This is on the PV and it is very close to the panels. Apparently panels doesn't have any protection. Like microinverters that you switch off this part, maybe. So it was on the cable just out of the this panel section. And you cannot do really anything about it. What you could do, you can take isolation and then try to cut it. But this is a dangerous thing to do. You need to have OLPP and you have someone who is trained to do it very fast on site. Otherwise, you just wait, because you still have a sun. It still generates the power. What I've seen, there are some extinguishers which can cover the PV and then they turn into some kind of rubber, so you can take it off and, let's say, temporarily shut off the power on the panel section. If you have something like this, maybe it will help. You might have microinverters between panels, so the microinverters with some kind of Arclash IFD, Arclash detection, will shut it down, or you can prevent it by hardware. So generally the idea, as far as I see in PV, is to install a lot of, so the MC4 is a problem, the connector, which is sometimes overheating and they have a serious arc. Usually it's not the arc flash to face to ground or face to face. Usually it's in series on the same phase because of overload, whatever. There's like goats sometimes there's a lot of animals around. So the problem is that if you cannot detect it, the inverter might switch off. It doesn't matter. The protection somewhere there before might switch off. It doesn't matter. You still have a source. Power is coming to the point where the arc flash is happening, and at this point you cannot do anything. Then it will keep going until it will burn, probably the whole panel or at least the cable. And you just have two options: it will just keep burning, or it will just burn out and stop. So it is a problem. That's why I don't have a PV on my house yet, because I'm a bit afraid of fires from it. It is not direct answer to your question, but there are no direct solution for it. And I've seen recently there was a post because for the MC4 connectors you have some kind of I'm not sure what the material is, but you have called arc box, which try to contain the arc inside this place, and once it burn out, maybe it will disconnect. So at least you prevent the fire spreading. But I've seen someone did something similar. I think it's plastic, but they put some microcapsule fire suppression tape inside. But I haven't seen the test, and I'm pretty sure it will not work. It might work for fire, but not for the arc flash, not for a serious arc. So similar question from Vikrant: which are the renewable sources having more chance to get arc flash, solar and wind? So in my feeling, solar, because solar is passively working when there is a sun. So there is a sun, we this thing will be energized passively. It just goes with the power. You have a voltage. If something happens, and it's lower on the ground usually, so you sometimes have animals. People are doing things around it. There's a lot of sun and heat, generally around this topic, around PV. So I'm pretty sure there are more fires from solar, unfortunately. Also, they have much more equipment, I would say. And in wind, um, the problem with wind is not that you might have a Arclash, because you still might have as a normal equipment. The problem is that when it's operating, when it's turning, the generator is running, you have a usually much bigger generators, like 2 megawatts up to 15 now, I think, on offshore, and you have a confined space. So here you can just look at it as the person that was recording, and generally slowly go away. From offshore wind turbine, it's very hard to go away. And if this thing start to burn, set on fire, you need to be very fast and you know the procedures to escape. So I used to design wind turbines, and if you go up, like in direct drive, when everything is on the top in the cell, uh, it's not that easy, really, if you never did this, to evacuate. And if you have a fire, depends where the switchgear, everything is mounted. Usually it's on the bottom, but sometimes on the top. It's very hard to. It's like very stressful situation. And I don't know if you ever been, but if the wind turbine stops, because it might have emergency stop, it was operating, something happened, and you stop it because it still can. It is shaking, and it's shaking a lot. It's not that it's just stand still. It will shake for 20, 30 minutes. So it's very hard to escape. Um, it is very specific topic. So I think, but I still think the fire problem, Arclash problem, is more on solar side and battery energy storage, as far as I see the news. Wind also catch fires, a little bit different way. And but I would say they typically they will probably have much more energy available, because they are much bigger systems, like 500 megawatts systems, wind farms. Uh, so this is interesting question from Alexander. Sorry. So how often have you experienced short circuit design violation of medium voltage switches at industrial grids? My still little experience shows that sometimes the contribution of consumers, dual asynchronous motors, is forgotten. Uh, well, I can tell you it is on medium voltage. It's not that often. Sometimes it happens, but it's not. Usually they are, I would say, overrated. Bigger problem might be loading, that sometimes is not and protection, proper protection. But I don't see really that often medium voltage issues with the short circuit rating. But it really depends from the utility grid, I would say. Much more I see the problems on the low voltage. But I had a project which was recently new project with a lot of big companies, when generally they have to change the rating of breakers and switchgears a few times before I finish the study. So yes, it is happening, even if you have a lot of people involved, because they didn't take into account a lot of motors, they didn't take into account generator, and they didn't take into account the operating modes. So I think it's one, what you say, motors, generators, battery energy storage system, and PV systems, which are sometimes installed, and UPS system. But for UPS, it's a little bit different because it depends how they work. But this kind of topics are the most topics I see that I overlooked. And then there is a surprise, yeah, it doesn't work, or you have a violation on short circuit, especially on the peak value. If you have a generators in the system, you will see actually more problems on the peak value than on the so-called making current for the breakers, because they always have two rating. You always see ECS or ECU rating on the breaker, like in Europe, which is for example 50 kiloamps. But you know you have to remember that 2 times 2 is 100 something, 12, 15 kiloamp is a peak current associated with it. And peak current is just peak current. If you violate it, and this is not okay, and you have to change to the next size. I hope this answers your question. Um, Ian, you're a good one. So, question from Ian is very good. Why do you think the ISC hasn't adopted IEEE 1584 equivalent? I think the reason is we focus on elimination control procedures. This is where you should be focusing attention. PPE is the last line of defense. Yes, I think that's pretty much what the thinking is in IEC world. That we try to fix things with the products, we try to fix things with the papers, and accident still happens. Like last one, that was now that was in US, but then before that was the case was closed in UK about the generator connection. So the problem is, as far as I see, I don't know why ISC still don't want to catch up on IEEE 1584. For me, the best idea will be to adapt IEEE 1584, not even NFPA 70, but just IEEE 1584, because that's actually what we are doing. And it is allowed on a lot of local regulations that we can follow this when we talk about the Rflash, because there is really nothing else. I know that there is DGUV in Germany. They make their own approach, different approach to Arclash calculation. But I can just tell you, I did few projects with double calculations, and the conclusion is that yeah, it's not the DGUV results are um, um, much more higher, but also they are much more conservative, and it doesn't looks like it is correct in practical way. So sorry for saying this, but it doesn't look good. I think they still have a lot of work to do. Uh, what I'm a bit afraid that most likely the IEC, like everyone else, they will try to make their own way of doing a lot of things instead of adopting IEEE 1584. And I would prefer that IEEE 1584 will be generally adopted because it's international standard. I'm just adapting this to IEC world when I do calculation. I don't follow NC, I follow IEC because everything else fits, and it has to be in line with the protection rating and everything else, and it's relatively easy to do. So I don't know. I don't have answer for it, but I think the other part of what you said, that we in IEC we focus a lot of on product. So someone says we have arc-rated switchgear, you are safe. We have switchgear which is 50 kiloamp and you have 40, you are safe. And people don't get into account that yes, we have a human error. Yes, accident still happens, and yes, Arclash is not sometimes related with people what they are doing. Sometimes it's just with the condition of equipment. So I'm not sure why this is happening. I think it's a big lobby on manufacturers, and big manufacturers would they convince people that yes, everything we do is safe, and we simply ignore the chance of things to happen. And if you go on sites and you see equipment there, it is even if it's new, sometimes it's already not maintained, not up to date, and you might forget about it. I don't know how to compare it. I say PP is last line of defense, but at some point PP is a must. So you need to have something, but you need to know what. And that's the point. It's not that we always go with PPE, because I always do a lot of other things before. The idea is that you need to go with PPE at some point, but instead of going 40 calories, we after all changes you go with 4 or 8 calories, which are generally as a thing as I'm wearing now. So that's the idea behind it. But it would be nice if someone goes with proper rules adopted in IC, and we don't have to really go around this. Uh, Said, so how to calculate average on CTs and PTs? Well, this is interesting. To be honest, I never did this. I know we can, but it would be very low, like the CT itself, because I assume that you would like to talk about the CT leads and PT leads that are going out. And typically, you don't expect a very high current there. But I can get it because this is a control signal, so we actually never do it. But if you would like to do calculation on CTs and PTs in your medium voltage switchgear, you still can do it. So this will be just like everything else. But I will stop on the primary side. I will not go to the other one. Doesn't make sense. What I will do generally, I will just calculate the as all the systems. So this will be like the one feeder. You add it to the main. You take it from the main bus bar. You calculate what is your short circuit current at the CT or PT side, and you check your protection because you sometimes have a fuses there or something like this to protect, and that's it. I don't think you have a huge energy there, but because they are usually like 4 square millimeters, 6 square millimeters, or something like this. So I don't think you have a huge energy, but yes, this way you can do it. At least in my feeling, because it's still 400 volts or 690. It's still a normal feeder, and there is protection behind it. But I will not go on the low voltage side. You might do exercise with it, so it's actually a good point. But actually, I never did this, to be honest. You are the first one asking about it. Let me go. What else? I see some discussion with Callum and Ian, so I will leave it there. But we have a question from Mr. Khan. So if you are limiting Rflash study scope for panel boards rated greater than or equal 60 amp, does that still be called a conservative approach, or there are better way to perform this study holistically? Well, the problem with the scope is that in past, and I do still the same thing, we always start with in IC 63. So we always go with down to 63 amp or protection level, actually, not panel board rating, but protection level rating, because if you go on site that is existing, no one knows what is the short circuit current at this panel. So that's the point. So if you just enter the random plant and you say, okay, where is your 208 volts, 2000 amp short circuit current panel list? So we know, okay, this panel is 2500, the other one is 10,000, this one is 1500 amp short circuit current rating expected. And usually you don't have, it's like 99, or actually I'll call it 100%. You will never get this information. So you have to start somewhere. So what I did, and I know a lot of people are doing similar way, we said we go down to 60, 63 amp protection level at the first phase. Usually if I identify panels on site, which are like 50, 40 amp, I still include it in the study just to have all the panels, not machines, but all the panels. So this is a very good first approach to site. The problem is, okay, because if you are in US, it's a little bit different than if you are in Europe, of course. But so this is, for me, is the first approach. We go this way. Sometimes people have, okay, strict requirements, and this is going from customer, and I don't really fight with it. If they would like to have everything included, we can still do it. But this is a little bit different story. And for me, again, is 60, 63 amp is the bottom level where I go. Typically below 63 amp is unlikely in normal AC systems to have energy above 1.2 calories per square centimeter because of the protection. Because if you don't have a protection, of course, it's different. But if you have a protection like 63 amp MCB or fuse, it will be below 1.2 most of the time. You might just have to be careful on kind of DK characteristic MCBs. But this is my first approach as well. And if we go above, below this value is mainly driven by some maybe 5% panels that are left there somewhere, like physically panels, isolator switch panels that you can physically open, that you can still go there, and then we just finish this to clear missing 5-10% of equipment, which is not identified before, but it is on site, and there will be a question why it's not included. So that's just because of this more practical engineering approach, I would say, not really driven by any requirements. And if you would like to go by IEEE or NFPA, then we have to include everything which is above 2000 amp short circuit current level and above 208 volts, which means sometimes quite a lot of equipment in plant. But to get know all the data, you have to run short circuit current study. So generally, you have to model everything at this point. So that's why I explained we always start with 63 amp as a reasonable approach. So question from Kenk. Any examples on Arclash calculation for the various voltage levels or on the various form of main switchboard panel design that you mentioned? Yes, probably you can see it before. Technically, this is in IEEE 1584, where you have different configuration referring different switchboards, switch gears, and so on. There is a difference as well, because if you have what I can tell you, the across different voltage, across different there's always the same thing in projects. So it's not about the voltage level, it's more about the protection. I would call it a short circuit current, because if you have mm, I can show it in the examples. It is in my previous webinars, probably you can find it there, but it's not focused exactly on this topic, because you just see the results from my projects, which are real projects. And I can tell you that from my experience, if you work on medium voltage systems up to 36 kV, for example, 11 kV to 36 kV, Arclash is usually not that big issue. So it is there, but because of the internal classification design of panels, it's not that we ignore it, but we just acknowledge it. And yes, but we are safe because we are in the range of the internal arc classification. Usually the protection is easy to adjust and it's okay. So you can make it lower. And I can tell you, I never actually have medium voltage panel that was above 40 calories. They are usually somewhere between 2 to 20 maybe. Uh, and after adjustments, they are getting better. Usually the bigger problem is on the low voltage systems, where you actually go to bigger currents, short circuit currents, and sometimes surprisingly high tripping times. So that's the problem, and depends on the configuration. The worst thing that you can have is, for example, the main breaker when you have this will be HCB, which is horizontally directed into you, which you create kind of ejected arc towards your face or your torso. This is generally the considered as a general worst case. There are some different. That's why IEEE did a lot of testing. So I'm not going to discuss IEEE because it's not really it's not going that technical. But the point is that sometimes you have a isolation inside the panel when it can bounce back. So the arc is generally not really easy to predict how it will behave. That's why IEEE did a lot of tests, over 2,000 tests, and they found out, yes, if you have some isolation below the cables or below the breaker, it might bounce back to you, which is called VCBB now configuration. If you have the main breaker and you see, sometimes you see the connections above, which are not protected with anything, and they are directed towards you. So if you initiate arc there, it will just go to your way. And I think that generally that's what it is. You try to avoid this configuration when the arc is will be directed towards you. So I show it in some of the myths or some of the webinars there when there were pictures of the bus bar directed into your face, because it was when I was making the picture there. Question from Visha. Oh, we are already 1 hour, so this is going. I think we still might do something like 15 minutes, and then probably we can end. So, what are the inputs required from the switchgear vendors to perform Arclash studies? Well, I assume that if you do the new project and you just have a documentation, then typical data that you will find on the nameplate. So usually you have a cut drawing that you can see how is the core orientation of the panel. You will have the short circuit rating of the panel, like 50 kiloamps, 1 second, which is important to check to evaluate for the short circuit. You have protection inside, which is so from switchgear point of view, only switchgear. Size, because dimensions you would like to know. Design, is it 4B, 4A, how you have a separated protective device? So is it really separated, or it's like in one enclosure where you can touch everything? And rating of the switchgear itself. Those are the, I would say, three core things for you to have. And then switchgear itself has protective devices inside, like fuses, breakers, and you need to all the data about the fuses and breakers and settings. So how they are set, overcurrent, ground fault protection, what generally data from the nameplate of the protection and type of your protection unit and settings. So this is like if we talk about the switchgear only. So, question from Hannah: Is there a piece of equipment or a stage along power flow infrastructure which is more likely to be affected by Arclash? Um, I would say everything which is so. If you would like to consider something high as a high probability of Arclash to happen, aside of activities from people, so high probability would be always anything which is exposed. So if you have any bus bar going outside of your transformer, um, if you have bad maintained equipment like old one, it is highly likely that something can happen. If you have, I would say sometimes you have a switchgear when the bus is not on top but it's on the bottom. Don't ask me why. Uh, so this one is more likely to have an arclash because gravity works. So if something falls down, it falls directly on the bus bar. So I can tell you that when I go on site, I do also visual check, and because we don't do any risk assessment like in strict word, I also identify shock hazard issues, which are at the same point arclash hazard issues. So you will see, and I think it was on one of the webinar before, you will see things like exposed equipment. It is more highly very high likely that something might happen. You might have missing IP covers. If, for example, you have a main breaker and all the lugs are exposed. You might have transformer, of course, but transformer are generally the same topic. Usually they are not easy to access and they are sealed close. And but if you have one that is standing freely somewhere, this is not a good idea. You might have damaged cable connections, so things like this. But there is no, as a rule of thumb, there is no equipment that you should consider bad for Arclash. All the connections, those are the topics. But if you just buy things, you build new equipment, new installation. As a rule of thumb, you assume that everything is done according to the rules, according to the standards, and it's supposed to be okay. So that's the kind of IC approach, I would say, in our world, that we build it and it's okay, it's new, it's fine. Um, but I can tell you that everything which is a low IP rating, switches which have low IP ratings, when they will be easy to open and access everything, um, transformers which are not covered or easy to access, and in my feeling, secondary equipment which is most time um, maintained by maintenance engineers, but it requires a lot of maintenance, a lot of measurements, a lot of touching, doing something, switching, those kind of equipment, because you interact a lot with it. So we are going, I think that was the last question I see. I can go with if I miss something, but I think not. So what I can add from my perspective is that you see video like this. This is example that I also posted before on LinkedIn. Shanghai. So this is happening in the industrial side. All the things which are that maintained, not a proper condition, and it is happening on the supply side. I think it's hard to see. You see the protection doesn't work. If you have an alarm, it doesn't work because it's time is extended. And I have some photos of this because this is crazy low. It's not even half the comment. And all of accidents like this, when they happen, it's usually the problem is, equipment was damaged, not maintained, or maybe breakers were not maintained properly. So they detect something, but they were not able to react. It might happen. It will just stuck. And also the other point is that you might have a lot of let's say, short circuit current violation. So if you just look on the installation in the facility like this, it looks like everything else. So on the first view, you might find some visual issues like, okay, this is damaged, this is something wrong, this is old. There is no test labels anywhere, so we don't know if that was tested somewhere last 5 years maybe. And you don't have any other. So you might assume, okay, this is in the bad shape. But it's really you don't see internal on the breaker. Of course, you will not make it. So you have to assume, okay, this is not good. And when you do the Arclash study, because this is one word, but it means we do short circuit current calculation, equipment evaluation, we do protection check, sometimes load flow. It's not really required, but you might do it as well, and an arc flash. And then you do recommendations to fix a lot of problems. And again, the same calculations. And the point is that if you do this, then you start to find out you have a short circuit current value violation, so this breaker is not okay, it has to be different or higher. This panel is not rated properly. We have a problem with protection, like this video, when it takes ages in electrical world. We have a problem with selectivity, which sometimes you can live with this, but you just need to be aware about it, and so on and so on. So there are a lot of things like this, and usually it's very hard to, in my opinion, that's why I do a lot of calculations. That's why it's very hard to, if you just look at it, it's just equipment as equipment. And there might be two identical switchgears in the same facility, and they will have a different results. The result might be very different, to be honest. It happens very often in my feeling and in my projects, when people just see this panel is 2 colors and the other one is 25. And I have to explain why. So that's why the report is in the full version always. So I think we went through all questions. The time is now because it's 1 hour or something. So it went good. I'm just checking if I missed something or not, but I think not. If you would like to have some topics to think about, I can tell you that yes. Let me just go back to this. Um, Let me skip because there is a body injury, so I go fast. Sorry. I can tell you the last time there was an accident, that what I was talking about in UK. So there was a case closed now. They paid £1 million fine, which I think the fines are much higher than in the US even. And recently, also closed case was in Cleveland. Like this month is, I just hear a lot of news, and they pay 3.6 million, but they actually have two accidents on mini voltage and low voltage and some near miss and a lot of other violations. So this is far away for anything that you can improve situation. To be honest, it would be much cheaper to actually go to with Arclash with all the PPE, all sometimes hardware even improvements, than pay this fine, and also to train people. And there was one accident yesterday. I just saw it at Google in Iowa, where there's 3 people injured. I think in a medium voltage station. So I'm still waiting because it's very fresh. It was yesterday or 2 days ago, and this is on the data center, which, as far as I know, they are because I did a lot of studies for data centers as well, and they are usually on top on hardware solutions. So I'm really wonder what happened there. So I'll be keep looking for the news and updates and maybe follow up report if something will happen. If you are in this area, you know that it's very hard to find any detailed information on accidents, and a very detailed one when someone will tell you, okay, this happened, that's why we did this, because it's no one really wants to share it, I would say, unless it's publicly available and has to be done. And what my plans are now, so that was part of the things that we might discuss if we don't have any questions. But what I'm planning now, so there was a few webinars to go. The next one will be in September. So I'm working with some company called 21 Risk, and they will do a lot of nice. You might go to the website, which is called the same way, 21risk.com, and so I'll be announcing the webinar soon, and we'll try to make some. So they have very nice tool for overview for auditing for the risk insurance companies, and I'm helping them to introduce the Arclash risk assessment to it, and we'll be rolling out the webinars and how it works. So feel free to join me in September. As I said, there will be a webinar on DC Arclash because I think it's important, and a few people ask me about it. And generally, it was interesting for me, but it was not on my list because I have something different. But I thought, okay, I can shift things and add DC Arclash here and generally talk about it because there is a lot of accidents about the battery energy storage systems, PV fires, and we also have a lot of other DC systems coming on EV electrical vehicles, and they are now, as far as I know, above 900 volts, even above 1200 volts DC system. So this is getting serious. And I also have pending webinar on the PPE selection because I think I never talk about it. How to properly how I work with the PPE selection at the end when we finish everything and we have to select PPE for the sites. And I'm helping people with it, so I have to also educate myself a bit deeper many years ago to go to it and provide proper help. And it's not really a secret that I work with some companies that they manufacture PPE because I have to help my customers at the end. So I thought, okay, this would be good to show how I work because I think there are a few mistakes people are generally doing, and that's why I actually started. And it would be probably good to explain it. And there are one or two maybe webinars left there, and we'll see how it will go to the end of the year because I'm generally busy, but I'm trying to do at least one webinar per month. So, and if you don't want to miss anything, just go to visit my website, mrpowertech.com. You should see some pop-up screen, and if not, just go to the webinars and there is a newsletter. So instead of going through the LinkedIn, you might sign into it, and there will be direct linked to the webinar and reminder. So you can generally click to it and attend on YouTube or on LinkedIn, and also have a follow-up email, which is somewhere on LinkedIn as well on my newsletter, but I think this is go directly to your mailbox, which I think is for me it's more convenient, so I don't have to do it many times. So that's the idea. That's all for today. If you never watched my previous webinars, go to the YouTube. You might as well watch it there. I think there are a few six. That this is seventh one. So be my guest. I will be very happy if you subscribe to it and if you hit follow me and my company on LinkedIn. It will help me a lot. So thank you all for joining me today, and I hope you enjoy it and you like it. And if you have any other questions, feel free to write it in the LinkedIn or YouTube, because we still can follow up this conversation, and this video will be available on LinkedIn as well. So thank you very much all.